This is lesson 55, geometric sequences, or review of all sequences, geometric and arithmetic. Our first problem, or our warm-up, given the first term and the common difference of an arithmetic sequence, find the term named in the problem and the explicit formula. So our general form for an arithmetic sequence is our first term plus n minus 1 times our common difference. So we're just going to plug in what we have. So it's our first term here is, our first term is negative 11 plus n minus 1, and our common difference is negative 200. So we're going to simplify this by distributing our negative 200, so we get negative 200n plus 200. And now we're going to combine our like terms. So we have our explicit rule being negative 200 times the term we're on plus 189. So now if we wanted to find the 10th term, we'd say a sub 10 equals negative 200 times 10 plus 189. So that makes negative 2,000 plus 189. So the 10th term would be negative 1,811. Homework questions we'll do in class. So here we want to tell if the sequence is arithmetic, geometric, or neither. So what are we doing from one term to the next? Looks like from one we're adding 2, adding 2, adding 2, so that makes that arithmetic. Here we're adding by, what is that? Adding by 5, and then we're adding by 1, and then we're adding by 3. So that doesn't have anything. Can we multiply by something? Well, here we'd need to multiply by, more than 2, but here we wouldn't. We'd be multiplying by like 1 point something, so that's neither. Here we're adding by 2, adding by 4, adding by 8, and you can kind of see a pattern there, but check out this pattern. 2 times 2 makes 4. 4 times 2 makes 8, 8 times 2, so that's geometric. This would have a common difference of 2. This one has a common ratio of 2. Write the first 4 terms of the sequence. So a sub 1 would be 1 times 1 plus 1. So that would be 1 times 2, which would be 2. A sub 2 would be 2 times 2 plus 1, which would be 2 times 3, which would be 6. A sub 3 would be 3 times 3 plus 1, which is 3 times 4, which would be 12. And the fourth term is 4 times 4 plus 1, which is 4 times 5, which makes 20. Look at these numbers: 2, 6, 12, 20. What are we doing? We're multiplying by 3, multiplying by 2, not multiplying by anything. That's some other kind of deal. Let's look at their differences though. Adding by 4, adding by 6, adding by 8, and look at the difference of their differences. Adding by 2. That's something special right there. We'll talk about that later on in the year. Next one, write a rule for the nth term of the sequence and find the sixth term. So what's happening here? Looks like well, I already see we're not going to add, so if we multiply by 3 and multiply by 3, so our common ratio is 3. So our general rule for a geometric sequence is a sub n equals a sub 1 times r to the n minus 1 power. So this is going to be a sub n equals the first term 5 times 3 to the n minus 1 power. And then if we wanted to find the sixth term, we'd say a sub 6 equals 5, our first term, times, what's our r? 3 to the 6 minus 1 power. So a sub 6 is 5 times 3 to the 5th power. And we could do that math later. 3 times 3 times 3 times 3 times 3. Well, that makes 9. And that makes 9. So that makes 81 times 3 is 243. So 5 times 243. So 243 times 5 is 15, 21, 12. So the sixth term is 1,215. Our next example, from 4 to get to 10, we're adding 6. From 10 to get to 16, we're adding 6. From 16 to get to 22, we're adding 6. So we have a common difference of 6. Our general rule for a arithmetic term, because this is or a sequence, because this has a common difference, is a sub n equals the first term plus n minus 1 times our common difference. So we're going to say a sub n equals 4, our first term, plus n minus 1 times 6. We'll distribute this. 4 plus 6n minus 6. Combine our like terms, and we get 6n minus 2. Now to find the sixth term, so that would be 6 times 6 minus 2, 36 minus 2. So the sixth term is 34. Write an explicit rule and a recursive rule for the sequence. So explicit and recursive. So what's happening here? Looks like we're multiplying by 3. We're multiplying by 3, so we have a common ratio of 3. So our explicit rule, right, a sub n equals our first term times our common ratio to the n minus 1. So we're going to say a sub n equals, what's our first term? 2 times 3 to the n minus 1 power. And there's our explicit rule. Our recursive rule, general form, is a sub n equals our common is our previous term, a sub n minus 1 times r. You could also see it written the other way, which is a sub n minus, a sub n equals r times a sub n minus 1. Same thing. So what are we going to say here? A sub n equals, what's our r? 3 times the previous term. Because that means the previous term. A sub n minus 1 means our previous term. This one, they're telling us that this is a common, that this is an arithmetic sequence because it has a common difference. So we need our general rule there. A sub n equals our first term plus n minus 1 times our common difference. plus sign. So this is 5 plus n minus 1 times 12. So this makes 5 plus, we got to distribute, 12n minus 12. And so our rule, when we combine our like terms, would be 12n minus 7. And our recursive rule is a sub n equals our previous term plus our common difference. These recursive rules aren't super strong because we need to know the term in front. We can only go to the next term. So this would just be our previous term, a sub n minus 1 plus 12. So we were at our first term. To know our next term, we just know to add 12. That would make 17. Okay, now we know our next term. Well, we just need to add 12. Our homework is 55.